Okay, YouTube, in our last video, we looked at how we could use information about a point in polar form, that is, use r and theta, in order to find its rectangular form, x, y. And in this video, what we're going to do is we're going to learn how to convert from rectangular coordinates, x, y, into polar coordinates, r, theta. And you notice it says it's a bit more complicated. The thing that makes this a little bit tricky here is that there are infinitely many representations for a point in polar coordinates. So that is to say that, if we were to make a little sketch right here, what we're going to say is this. If we had any point here, and we're in rectangular, so we say this is the point x, y, and we want to convert this into some r and some theta, what I want everybody to notice is that this x and y representation here is unique. And to say that it's unique means that there's no other way in terms of x and y to describe it than to say that you go left x and down y in this particular case. But with our particular case with respect to our polar coordinate, we could say that perhaps our angle here was this theta right here, and our r distance is that right there. But also, perhaps we could have had an angle here where we rotated negative and also out r. We say negative some other angle here, I call this phi. But basically, you can see that we could represent this as r comma theta, or we could say r comma negative phi. And so since there's not one unique way to do this, what we're going to do is we're going to make an agreement. And that agreement is that when we represent any point in the xy coordinate plane, something like this right here, we say x and y, what we're going to do is we're going to agree that when we convert this into polar, we're going to use a positive r value, okay, positive r value, and theta is going to be the smallest positive angle with the terminal side passing through xy. So that is to say that we could also write this in here, and I do want to write this in here. We'd say that our angle is going to be between and including 0 degrees. So here's theta, and less than 360, because if we're at 360, we'll just say 0 instead. But basically, we're going to choose a positive angle between 0 and 360 that passes its terminal side through this point xy. And so in this particular case, you could see that this angle right here, our angle would just be this theta right there. And our r value, we're going to assume that r is positive. So we're going to walk in the direction that theta is proceeding. And so using that relationship and remembering that x and y are related to r and theta thusly, we can see that x is r cosine theta, y is r sine theta. That would mean if we know r and theta, we could convert into x's and y's. What we want to do this time is ask, if we know theta and r, x and y. So if we know some point x and y here, we could say that this is some x and some y here. Could we solve for r and theta? And so the first consequence that I want everybody to recognize here is this. If we know x and y, then we know two parts of this right triangle right here. You can see that if I resketch our right triangle in the situation from above, we can see that it looks like this right here. And I know that our angle theta is on the outside. But basically, we could see that Pythagoras indeed does apply here. And that is to say that x squared plus y squared is going to equal r squared. So that being said, we're going to use this to say that if I know x and y, then I could take x squared plus y squared and I would have r squared. A general consequence of this is to say that r is always going to be equal to the square root of both. Well, I guess if we take the square root of both sides of this expression or this equation, we get just r is equal to the square root of x squared plus y squared. So we're going to put a box around that. And then also here, we would see that theta, the tangent of our angle theta here, if we were to take the tangent of this angle here, we would get y over x, correct? So we'd say that this is our y over x here. We would already know the values of y and x if we're given this point in rectangular form. And so to solve this, what we would have to do is take the tangent inverse of both sides. So I'm going to write this here. If we take the tangent inverse of the tangent of theta, we would get the tangent also inverse of y over x. And so we could say that because these cancel out, we know that theta, and I'm going to put a little prime here, but theta is equal to the tangent inverse of y over x. So this is really neat. These two formulas that we've got right here, we're going to use when going from rectangular, I'm going to abbreviate this here, to polar. I'm going to not abbreviate that one. But basically, we would say that if you want to know r and you already know x and y, we could say then you take the square root of x squared plus y squared. And if you want to know the angle we're talking about here, well then we'll take the tangent inverse of our y over x. So rule number one is going to be that we sketch a picture of this, certainly, but you could see those conclusions that we've drawn here are also listed here. To convert from a point being in rectangular to polar, we would say that you want to plot it, of course draw the picture, and then say find the distance from that point to the origin by using Pythagoras. And then the last thing we'll do is we'll talk about our angle by solving this equation here for theta. Tangent of theta equals y over x. So looking at this first example, it says, let's find the polar coordinates of the point whose rectangular coordinates are -1, comma, square root of 3. Now, first thing I always see that when we do problems like this for the first time for people, they're like, how do I graph this? It's got a square root on it. But the thing that we kind of want to recognize here is that the square root of 3, and we can get a decimal on this, is about 1.717, I think, ish. But 1.7 is a safe bet here. Basically, what we know is that we're going to go left 1 and up a little bit more than 1, but not as much as 2. We know that the square root of 3 is between the square root of 4 and the square root of 1, and so we know that this value has to be somewhere between 1 and 2. And so basically, when we sketch this, it just needs to be a rough sketch. Let's do this. I'm going to put 2 notch marks to the left. I'm going to say that this is -2, and I'll put 2 notch marks up. We'll call this +2. But we could see that we would go left 1 here, and then up the square root of 3, which would be about 1.7. Let's put this in a different color. And one thing that I want to do here is I want to label this. We went left 1, up the square root of 3. So now, what we're trying to find here is the angle that this makes with our polar axis, which is on the positive x-axis here. And remember, we agreed that we're going to choose the smallest positive angle that does this. So you can always look at this as being some angle that starts at the polar axis, or 0 degrees, and wraps around counterclockwise. And so this would be our angle here, and that's one of the bits of information we're trying to find. But the other bit of information we're trying to find is r. And so, I don't need to leave those question marks there because they're going to be in the way, but we'll find those values as soon as we cast down here our altitude and list out the other parts of the triangle we know. And so we knew going into this that x equals this and y equals the square root of 3. And so we could label the parts of our triangle here. We know y is the square root of 3 and our x value is most specifically -1. And so here's what we're going to do. Start with the fact that we want to find r. Now the neat thing about this is, of course, remember, x squared plus y squared is r squared. So if we're going to solve for r, I'm going to recommend that we get used to saying that really it's just the square root of x squared plus y squared. And so we're going to fill this in with our values of x and y here. And so because we have an x value of -1, let's go ahead and fill in our -1 here. We get -1, and over here we get the square root of 3. And so we'll go ahead and simplify this here. It's still the square root, but we get -1 times -1 is 1. Plus, now the square root of 3 times the square root of 3 is just a 3. Looks like this comes out to be the square root of 4, which is plus or minus 2. Now, looking at this, remember that r is always positive. So we're going to say that r is 2, and that's one bit of information we need to write this point in polar coordinates. We say 2 comma something. Now, we need to find this angle, and one thing I notice is this angle is somewhere between pi halves and pi. Or if we're doing this in degrees, it's somewhere between 90 degrees and 180 degrees here. The interesting thing about it, however, is this. When we set up our equation, tangent of theta, this is this second equation right here, tangent of theta is y over x. We're going to put our y value over our x value here. Our y value is √3. We get an x value of -1, so -√3. And so to solve this equation, remember, to solve an equation that looks like this and you've got your trig value isolated, we're just going to undo our trig value with an inverse trig function here. We'll do tangent inverse since we're taking the tangent of our angle. And so these values here would cancel out, and we're just left with theta on the left-hand side. And now theta is still equal to tangent inverse of -√3, but here's all we want to know here. We would say -√3. If we take the tangent of -√3 here, I guess I don't need to sketch this out, but basically what kind of a reference angle would we have here if tangent came out to be √3? And so knowing your reference angles here, we would say that this would be a pi-third reference angle or a 60-degree angle if we're talking about degrees. So the interesting thing is up here, you notice that I wrote theta prime is equal to tangent inverse of y over x. And that's exactly what we did here. We took tangent inverse of our y over x value, or -√3. But when we wrote theta prime, it was because what we're getting here is a reference angle. So I do want to show you that we could even find this on a calculator. I'll click on here. We'd say we'll do a tangent inverse of negative the square root of 3, 2n parentheses, and it says -60 degrees right there. We just want to keep the fact that it would have to have been a 60. So the reason why I say this is because when you sketch your picture, and it is an utter necessity that you sketch this picture, the reason why is because when you find your reference angle, you're only finding this part of your triangle. So that's not really telling you what theta is here. So to diagnose what we could here, we could say that if I know that this is 60 and these two angles together, theta and 60 make a 180, then we could say that this is 120 degrees right here. And so the other part of our ordered pair is 120 degrees right here, or I do want to make sure that we write this in radians as well. This would be 2 pi thirds radians, 2 comma 2 pi thirds. So let's take a look at doing this on your own here. I would encourage you to pause the video and give this top example a shot here. Graph the point 1 comma negative root 3 in rectangular form, and then convert this into polar. So if you're wanting to see the solutions now, you've sketched out your own, let's go ahead and take a look. And we'd say that graphing this, first of all, we would go right 1, here's 1, and we'll go up the square root of 3. If this is 2 right here, then the square root of 3 is going to be somewhere, about 1.717. So let's go ahead and talk about this point right here. We already know that this is 1 comma, and you know what? Absolutely just made a mistake here. It's negative root 3, isn't it? So let's go down negative 2 here. We say our point would be down here. That's better. So when we talk about this, we could see that already we know that this is a 1 here, and I'm going to erase this 1 right here, but we're going to write negative the square root of 3, but also that when we write this in polar coordinate form, what we're looking for are two things. We're looking for our theta value, and we're looking for our r value. And so using our formulas here, starting with our first one that says, look, if you know x is 1, and y is negative root 3, then what's your r value? And so we'd say r, again, is always the square root of x squared plus r squared. In this case, we get the same values that we did last time. So we get the square root of 4, which is going to come out to be an r value of 2. So our r value is 2 here. We assume that r is positive when we express this in polar coordinate form. And then we would say that what is our angle? Well, what we're going to be after is the reference angle right here. And so we could see that the tangent of this reference angle, I'll even write theta prime right here, the tangent would be opposite over adjacent. We could even say, opposite over adjacent here. It's SOHCAHTOA math, negative root 3 over 1. But this is the same thing as y over x anyways. And so we're going to go ahead and take the tangent inverse of this. So we say theta prime, our reference angle, is the tangent inverse of negative root 3, and what we get is a 60-degree angle. As a matter of fact, we get a negative 60-degree angle, but all we care about is the fact that that's 60 degrees. So the question really becomes, well, then what is our angle theta in standard position here? And we would say that that angle there would have to be 300 degrees. So to write this in polar coordinate form, we would say that really the point 1 to the right down negative root 3 is the same thing as 2 in a 300-degree direction, 2 out from the pole in a 300-degree direction. So what I want to talk about before we seal this video up is basically this, a couple of situations here where your points that you have in rectangular form are already lying on a quadrantal angle. And that is to say that, just go ahead and look at this example with me here. It says find polar coordinates for the point whose rectangular coordinates are these here. So we say x is negative 2 and y is 0. Always why we draw the picture is because if we go graph this right now, we go left 2 and up and down none, you can see that this point is right here. And really what we're after, of course, is what is the angle, okay, in standard position that we get here, and also how far away from the origin are we. And so what we're seeing here is that in a 180-degree direction, if we were to walk out 2 units in that direction, we would be at our point. So this point here, negative 2, 0, negative 2, 0, it's a lot easier to just draw this picture and write this as 2, 180 degrees just by observation. Now, could we have used the methods that we used up here? We certainly could have. We could have said r is the square root of, I guess we better do our x first, x squared plus y squared here. And so we get the square root of really 4 plus 0, or the square root of 4, which is equal to 2 here. And in this case, we'd say, what is this angle? I suppose we could do tangent of theta is our y over our x. So 0 over negative 2, or 0. And we would say, well, taking the tangent inverse of 0, let's see what we get here. Taking the tangent inverse of 0. Should get 0, but I want to show you. So we get 0. So what this means is our reference angle over here on our picture is 0 degrees, which obviously by observation it totally is. So what I want you to do is, again, pause the video. What I want you to do is find 0, negative 4, which is in rectangular form. Okay, I want you to put that into polar form, and then unpause it when you're ready to go. If you're ready to see this answer, let's go ahead and take a look here. We'd say 0, negative 4. So we say 1, 2, 3, 4. If we go down 4 and we graph this, and I'll label this here. As a matter of fact, let's just do this. We say 0, negative 4. Now you have to believe me. We'd say that our point here in rectangular form is this, but when we talk about this rotating away from the polar axis, how many degrees are we talking about here? What would our theta be, and what does our r have to be? So just by observation, what do you think about r here? 4, right? And then what about our angle? 270 degrees, or we could say that this is 3 pi halves radians, but this is our angle standard position. So this point right here is also 4 comma 270 degrees, or the same thing as 4 comma, and we would have 3 pi halves here if we're working in radians, okay? So again, using our techniques up here, we say if we know x 0, y -4, then algebraically we get r is 0 squared plus -4 squared. So we would get here the square root of 0 plus 16, which is the square root of 16, which is 4. So our r value 4 we obtained here. And also if we were to do a tangent of theta relationship here, where we get y over x here in this case, it's an interesting thing, but we get an undefined angle. And so in this particular case, what I'm going to tell you is that theta would have to be 90 degrees, and it's important to remember that if tangent is undefined, your reference angle is a 90-degree angle. The reason behind this is because, of course, examining on the unit circle here between, say, pi halves and negative pi halves here, where tangent is undefined, it's only ever going to happen at a value where x is equal to 0. So that's how we convert from rectangular to polar. Cheers.